The contact appeared at 0314 hours as a single return on the USS Winston S. Churchill's SPY-1D radar, a bright, fast-moving blip 40 nautical miles southwest, tracking northeast at 47 knots along a corridor that U.S. Southern Command had been mapping for 3 years. 47 knots. In a maritime environment where commercial fishing vessels average 8 knots and container ships push 20, that speed is not ambiguous. That speed is a statement. The operator ran the standard identification sequence in under 90 seconds. IFF interrogation, no response. AIS database cross-reference, the transponder signal that came back showed a 62-foot fishing trawler proceeding at 6 knots, 30 miles north of the radar contact's actual position. The two pictures, the AIS transmission and the radar contact, were irreconcilable. The AIS was spoofed, a pre-programmed false identity broadcast to confuse exactly the kind of check the operator had just run. The contact had no legitimate identity and was moving at nearly 5 times the speed its false transponder claimed. The tactical action officer logged it as a suspected go-fast vessel and initiated the counter-narcotics engagement sequence. To understand what the crew of that boat was relying on, you need to understand the engineering philosophy behind the vessel they were operating. Go-fast boats running Caribbean drug routes are purpose-built for a single operational requirement: crossing open water faster than anything that can legally stop them before they reach a coastal transfer point. The hulls are typically fiberglass over foam construction, 35 to 50 feet long, with a deep V-planing hull that lifts most of the structure clear of the water surface at speed, dramatically reducing hydrodynamic drag. The propulsion is 3 or 4 high-output outboard engines, sometimes modified racing motors, producing enough combined thrust to sustain 45-plus knots in moderate sea states. The low freeboard, flat radar profile, and fiberglass construction produce a radar cross-section approximately equivalent to a large piece of floating debris. Against a surface search radar operating at its nominal detection range, a go-fast at sea level in a 2-foot chop is genuinely difficult to resolve from background clutter. Against a P-8A Poseidon's AN/APS-154 radar operating from 20,000 feet with inverse synthetic aperture radar processing, it is not difficult at all. The P-8A was already in the operational area, not as a response to this contact, but as part of the sustained patrol architecture that U.S. Southern Command maintains across the primary Caribbean trafficking corridors under White House Counter-Narcotics Authority. The APS-154's ISAR mode doesn't just detect contacts. It resolves their shape at sufficient fidelity to distinguish a go-fast hull from a fishing vessel, a semi-submersible from a surface contact, or a narco-configured speedboat from recreational traffic. The return the P-8A generated on this contact was unambiguous. A multi-engine fast craft with no fishing gear, no visible navigation lights, and a deck configuration inconsistent with any commercial or recreational maritime activity. The crew activated the electro-optical/infrared sensor to confirm at 0321 hours. At altitude, the EOIR system zoomed to the contact and the operator's screen showed the thermal bloom of 3 outboard engines running at high power, the silhouettes of figures moving on deck, and what appeared to be bundles secured under a forward tarpaulin. Compressed brick cocaine packaging produces a specific thermal conductivity profile, cool against a warm deck, that experienced EOIR operators recognize. The contact was assessed as a loaded trafficking vessel with a high-confidence drug cargo designation. This entire intelligence package, the radar track, the ISAR imagery, the EOIR confirmation, the AIS spoofing documentation, was flowing into the Churchill's Combat Information Center via Link 16 in real time. The Churchill's Aegis system was not working from a single sensor's data. It was working from the fused picture of a P-8A at 20,000 feet, its own SPY-1D surface track, and the KH-11 reconnaissance satellite overhead that had been tasked to the contact after the initial classification. The Go-Fast crew was operating under the assumption that the ocean's vastness protected them. The network tracking them spanned 300 kilometers of altitude from the seabed to low Earth orbit. The Churchill's commanding officer authorized the intercept at 0328. The MH-60R Seahawk, we call sign Copperhead 11, launched from the Churchill's flight deck and descended to 150 feet above the wave surface, skimming the Caribbean at 155 knots toward the contact. Flying that low serves a specific tactical purpose. At 150 feet in reduced visibility, a helicopter approaches from below the target crew's natural visual scan horizon. The first indication the Go-Fast crew has of an intercept inbound is typically the rotor noise, arriving with almost no visual warning lead time. The initial contact came by radio. The MH-60R's crew broadcast on the International Maritime Distress Frequency and the VHF working channels simultaneously, in English and Spanish, identifying the Churchill and directing the vessel to stop engines and prepare for boarding. The call was repeated 3 times over 90 seconds. No response. The contact maintained 47 knots. The first non-lethal measure was a flare, a parachute-retarded illumination round fired from the Churchill's Mark 38 Model 2 25mm gun system to impact 150 meters ahead of the contact's bow. The round's trajectory was solution computed by the SPY-1D fire control feed, placing the detonation precisely ahead of the vessel's projected position rather than at its current one. The illumination flare burst at surface level, converting 300 meters of dark Caribbean into daylight-equivalent visibility for 30 seconds, and leaving no room for the crew to claim they hadn't seen the warning. The contact altered course 15 degrees to port. Speed unchanged. Copperhead 11 moved to a hover 300 feet off the Go-Fast's port beam and deployed a marking dye package, a fluorescent chemical agent that coats the target vessel's hull and superstructure in a color visible to both optical and infrared sensors for hours after application. The dye is not a threat. It is an irreversible mark that communicates a specific operational fact to the crew below. Regardless of what happens in the next few minutes, this vessel is now permanently visible to every sensor in the network. There is no darkness dark enough to hide a fluorescent hull from an EOIR system at altitude. The captain accelerated to 52 knots and turned toward a coastal heading. At 52 knots towards shallow water, the Churchill's 28-foot draft becomes a limiting factor. The destroyer cannot follow into the shallows without grounding. The Go-Fast captain understood this and was playing the last viable card in his tactical hand. Reach water too shallow for the surface combatant to follow, beach the vessel, scatter, and abandon the cargo. The Mark 45 Model 4 5-inch gun was used next, firing a proximity-fused high-explosive round that detonated in a fragmentation pattern 80 meters ahead of and 20 meters above the vessel's track. The Aegis fire control solution, fed by continuous SPY-1D tracking and the P-8A's radar data, computed the detonation point to place the fragmentation cone across the water surface ahead of the bow without the pattern reaching the hull. The airburst produced a wall of spray and secondary detonation pressure that the Go-Fast drove into at 52 knots. The impact was not structural. It was psychological and hydrodynamic, forcing the hull out of its planing attitude and momentarily reducing speed. When the vessel resumed speed and continued toward shore, 2 of the crew members visible on the EOIR feed moved to the stern and began pushing bales overboard. The cargo jettison is a standard late-stage response. Reduce the legal exposure, eliminate the evidence, accept the loss of the payload. Copperhead 11 flew a low-altitude gun run using its .50 caliber M3M door-mounted weapon, placing a burst 30 meters to the vessel's starboard side in a controlled demonstration of engagement capability. The remaining crew threw their hands up. The captain cut the engines. The VBSS team, vessel board search and seizure, fast-roped from Copperhead 11 to the now dead-in-the-water, Go-Fast in a 4-man lead element, secured the crew at gunpoint, and began the evidence documentation sequence. The jettisoned bales were tracked by the P-8A's EOIR sensor, their positions logged for subsequent recovery by Coast Guard assets. What remained on deck, still tied under the tarpaulin, was 340 kilograms of cocaine in commercial-grade compressed brick packaging. The crew, 5 individuals, was zip-tied, photographed, processed for biometric data, and transferred to the Churchill. The operation did not end at the boarding. The Link 16 data from the entire engagement had been flowing to Southcom's Joint Interagency Task Force South throughout the intercept, and the analysts working the network architecture of the trafficking organization this vessel belonged to had, during the 47 minutes from initial contact to boarding, been cross-referencing the vessel's route, departure time, and heading vector against 3 weeks of prior surveillance data. The coastal coordinates toward which the Go-Fast had been heading matched a warehouse facility that satellite imagery had flagged 14 days earlier as a potential transfer point. An MQ-9 Reaper orbiting at 25,000 feet from its base in Puerto Rico was already on station above that facility when the boarding was completed. The Reaper's sensor operator, guided by a designation laser from Copperhead 11, now repositioned toward the coast, put an AGM-114 Hellfire through the facility's roof at 0441 hours. The secondary detonation, consistent with compressed gas canisters used for product packaging, confirmed the facility's use. The coastal link in the supply chain was removed 73 minutes after the initial radar contact had appeared on the Churchill's display. The Go Fast was sunk by gunfire after evidence collection was completed per standard counter-narcotics protocol. A vessel used for trafficking has no legitimate future maritime purpose, and leaving it afloat creates a salvage liability in a busy shipping lane. The crew was transferred to a Coast Guard cutter for processing and eventual prosecution under U.S. counter-narcotics jurisdiction. The cocaine recovered from the deck, valued at wholesale at approximately $8 million, was catalogued as evidence. The strategic lesson this engagement illustrates runs deeper than the outcome of one interdiction. The crew of that Go Fast made a business calculation based on an accurate assessment of the odds against conventional maritime law enforcement. Coast Guard cutters with standard surface radars, operating in an ocean too vast to cover comprehensively. That calculation was correct against the threat architecture it was built around. It was structurally wrong against a fused network that sees the entire Caribbean from orbit, processes IFF and AIS anomalies automatically, maintains continuous P8A patrol coverage on priority corridors, and can put a Reaper on a coastal facility within the hour. The network is not trying to win individual chases. It is trying to make the entire geography of the trafficking operation visible from the departure point to the transfer node, and to remove as much of that geography as possible in a single engagement sequence. The Go Fast was not the target. The network was the target. The Go Fast was the datum that allowed the network to be mapped one node further. The question this engagement leaves open is about adaptation on the other side. Trafficking organizations with sufficient resources are already fielding semi-submersible vessels with diesel-electric propulsion that significantly reduce the surface radar and thermal signatures that made this contact trackable. The APS-154 ISAR detection that opened this engagement worked because the Go Fast was a surface contact with a conventional hull profile and high-power outboard engines producing a clear thermal signature. Against a semi-submersible running diesel-electric at 6 knots and 3 feet of freeboard in a busy shipping lane, what does the detection geometry look like? And as that hull profile becomes the standard rather than the exception, where does the P8A's next capability investment need to go? Leave your assessment below.